right, so we're going to be talking about factoring. Factoring is the undoing of simplifying. So when we're talking about factoring using something called the greatest common factor, if you recall the distributive property, if I had something like 3 times the quantity x plus 2, if I asked you to simplify this, you would use the distributive property to distribute that 3 in, and you'd multiply the 3 in to get a 3x plus 6. Well, now we're going backwards, and I'm going to ask you to take the 3x plus 6 and factor using the greatest common factor. And what we do there is we find the number that both of these terms is divisible by, and that would be 3. And we would take that 3 out, and we use division to rewrite the rest of our polynomial. A 3x divided by a 3 would leave us with a 1x, or just an x. And a plus 6 divided by a 3 would leave us with a plus 2. So notice we get the same exact thing as we would have if I asked you to distribute, only we're working backwards. We're undoing the simplification. All right, so in this part of your notes, sometimes greatest common factor will be abbreviated as GCF. So factoring using GCF is unsimplifying. The distributive property. And distributive property is multiplication, so factoring using the GCF would be division. So, looking at number 1, we want to factor this polynomial using GCF here. Both terms are divisible by 9. So I'm going to factor a 9 out. Now I'm going to use division to rewrite the rest. A 9x divided by a 9 is a 1x, or just an x. A 45 divided by a 9 is a 5. That is fully factored. You leave it like that because the directions are to factor, not to simplify. So we leave it unsimplified. That's what our goal is. All right, number 2 is a little bit different, because this time we are going to look at our numbers between an 18 and a 12. What is the common factor between them? What are they both? What's the largest number that they're both divisible by? That is a 6. And then now we need to be careful on this one because now I have common variables. In the first term, I have 6 x's. In the second term, I have 3 x's. So I must take out a certain number of x's, and since both of them have at least 3 x's, I'm going to take 3 x's out, so an x cubed. Now I'm going to use division here, and 18 divided by a 6 will leave us with a 3. I had 6 x's and I took 3 out, so now I'm left with 3 in this term. Plus, 12 divided by a 6 is a 2. I had 3 x's, I took 3 x's out, so I don't have any more x's left in that term. This is fully factored. Again, we don't want to resimplify and distribute back in. Now you can distribute back in just to check to make sure that your factoring was correct, but this is your answer. This is the answer I want. All right, number 3. Out of a 7 and a minus 21, both of these terms are divisible by 7. I have 2 x's in my first term. I only have 1 x in my second term. So both terms have at least 1 x, so I'm going to take 1 x out. A 7 divided by a 7 leaves us with a 1, and then I had 2 x's and I took 1 out, so I'm just left with a 1x, or just an x. And then a minus 21 divided by a 7 is a minus 3. I had 1x, I took 1x out, so I don't have any more x's left in that term. This is fully factored. Number 4, out of a 12 and a 32, the largest number both of these are divisible by is 4. I have 2 x's in my first term, but only 1 x in my second, so I can only take 1 out. I have 2 y's in my first term and 3 y's in my second term, so both terms have at least 2 y's, so I'm going to take out a y squared. 12 divided by a 4 is a 3. I had 2 x's, I took out 1, so I'm left with 1. I had 2 y's, I took out 2, so I'm not left with any more y's in that term. A 32 divided by a 4 is an 8. I had 1 x, I took 1 x away, so I'm not left with any x's. I had 3 y's, I took out 2, so I'm just left with 1 y. This is now fully factored. Looking at my next one, now when you can take out a negative number, if both terms share a minus sign in common, we are going to take that minus sign out. Out of a 9 and a 27, both are divisible by 9. A negative 9 divided by a negative 9 turns into a positive 1x, or just an x. And a minus 27 divided by a negative 9 turns into a plus 3. Now I would accept your answer if you just took out a positive 9 and you left it as a negative x minus a 3. I would accept that. All right, number 6. Both terms have a 3 in them. They're both divisible by 3, so we take out a 3. Now my first term only has an x. My second term doesn't have an x, so I cannot take an x out. But both terms have at least 1 y in them, so I'm going to take a y out as well. Now a 3xy divided by a 3y would just leave me with an x. And a 3y divided by a 3y is a 1. And I do need to write that x plus 1. It's not just going to be an x in parentheses. You need to write that plus 1 as well. All right, number 7. Out of all 3 of my terms, the greatest number all 3 are divisible by is 5. Out of all 3 variables, each term has at least 1 x, so I'm going to take 1 x out. 15 divided by 5 is a 3. I had 3 x's, I took 1 away, so I'm left with an x squared. Minus 25 divided by 5 is a 5. I had 2 x's, I took 1 out, so I'm left with 1x. Plus 55 divided by 5 is an 11. I had 1x, I took 1x out, so I don't have any more x's left in that term. All right, in number 8, out of a 3 and a 4, there is no common factor. However, each term has at least 1 x, so I can factor out an x. And when I factor out that x, I'm left with a 3x plus a 4 in parentheses, and that is fully factored. Number 9, out of a 5 and a 20, the greatest number both of those are divisible by is 5. Both terms have at least 1a, so I'm going to take 1a out. And both terms have at least 1b, so I'm going to take 1b out. 5a squared b divided by a 5ab is just going to be left with an a. And then minus a 20 divided by a 5 is a 4. And I don't have any more variables left in that term because I took out the a and the b. That brings us to the end of the level 1, which is factoring using the greatest common factor.